Hello everyone, and welcome to the second to last day of the unit, which is motion. So we talked about last couple units ago, I guess it was, that we know the position function is s of t, the velocity function is the derivative of the position function, and acceleration is the double derivative of the position or the derivative of the velocity. So we've done this before. What we're going to do now is just go backwards. So the velocity function is the integral of the acceleration function, and the position function is the integral of the velocity function. And that's all it's saying. You just go backwards. So no more really difficult integrating. It's just understanding how position, velocity, acceleration relate and how to move from each of those functions. So if we look at the first one, particle moves along the t-axis. Use the given information to find the position function of the particle. So we're given a velocity. We want the position function, so we have to go backwards. So we know position s of t equals the integral of v of t dt. Well, plug in there the integral of 1 plus sine t. So we got t plus, minus cosine t. Now, notice that it is not a definite integral. We do not have bounds, and therefore we need the plus c. So here is our position function. We're going to plug in 0 and negative 3 to find c. So we got negative 3 equals 0 minus cosine 0 plus c. Negative 3 equals cosine of 0 is 1. So negative 1 plus c. So c equals negative 2. So our final answer, s of t, the position function, t minus cosine t minus 2. Done. So the next one that we've got here is one that gives the acceleration function instead. And so we've got to use the information to find the position function. Well, we know that we can't just go from acceleration right to position because we have velocity in between. So we've got to find the velocity function. And so let's find that velocity function. We're going to get t cubed over 3 minus 3t squared over 2 plus t plus c. And just a quick thing that should say along the t-axis there. We'll use this initial condition to find c. And so we're going to get 0 equals 0 minus 0 plus c. And therefore c equals 0. Pretty lame, I know, but it does make our life a little easier. So we can state that v of t equals t cubed over 3 minus 3t squared over 2 plus t. We don't have a constant. That's kind of nice. So now our next part will be to find our position function. Well, we know the position function is the integral of v of t dt. And so if we take the integral of this, I'll get it up for you. We're going to get t to the 4th over 4. And that 3 still stays there because it's still 1/3 of that. If we wanted to look at it another way, we could have looked at it as 1/3 t to the 4th over 4. If you want to look at it that way, it's probably a better way to look at it. Minus 3/2 t cubed over 3. Plus t squared over 2 plus c. Let's simplify that just a little bit. T to the 4th over 12 minus, these 3's are going to cancel out. So t cubed over 2 plus t squared over 2 plus c. We've got to use our initial given condition to find c. Well, if you notice, we get 0 minus 0 plus c, and therefore c does equal 0 again. So it did make it a little nice for you. Our final answer, again, has no constant. It's just t to the 4th over 12 minus t cubed over 2 plus t squared over 2. And that's it. We don't even need to put a plus 0. You could have put plus 0 if you wanted to. So all we're looking at, if given the acceleration, to go backwards, you take the integral of it. And again, to go backwards from velocity, take the integral of that. Basic integration here. Make sure you don't forget the plus c. And there it is. Now, getting to things that actually are going to require some thought here, is displacement. Now let's think about displacement. If is just the change in position over time, the net area. So let's talk about if I start at time 0, if we take this as time, and I start at 5, and I end, let's say 3 seconds later, at 9, my complete distance, the displacement, was 4. I moved 4 spots. It's just the beginning, or the ending minus the beginning time. That's how much I moved. Total distance, though, is everywhere I moved. So let's just say here, we'll use the same example. I start at 5. What happens if I moved at 2 seconds to 1 and then back to 9? Well, my distance moved here was 4 and 8. My total distance would be 12 in this case. Moved from 5 to 1, that was backwards, 4, and then 1 to 9, 8. So my total distance here would be 12. My displacement, though, is still 4. So the total distance. Another way to look at this is if we look at a graph here. And I did this. So the area here is 3, the area here is -3. Our displacement, if we think of the integral, which is again just the integral from t to 0, t of 1, is 3 plus -3, and our displacement would be 0. But if we look at the absolute value, because there is no negative in absolute values, that we have 3 and 3, our total displacement is 6, because I really walked 3 and then backwards 3, and I've gone 6 total spots. That's for the total distance, but I've really not changed anywhere if I walk forward 3 steps and back 3 steps. So that's the difference between displacement and total distance. Displacement, just take the integral of velocity from the beginning to the end. Total distance is all about absolute value of that. You may do this in the calculator. Let me repeat, you may do the absolute value of this in the calculator. It will make your life a whole lot easier. So, let's use this. Suppose that a particle moves on a coordinate line so that the velocity is that, t squared minus 2t. Find the displacement from 0 to 3. So displacement, again, for this one, look at displacement. All we're going to do is take the integral of it. 0 to 3 of velocity, t squared minus 2t dt. Well, we can do this out. It's t cubed over 3 minus t squared. Evaluating from 0 to 3, we're going to get, when we plug that in, we're going to get 3 cubed over 3. Notice that 3 cubed over 3, the one nice thing about this is this is the power rule for, not power rule, the quotient rule for exponents. You're going to get 3 squared minus 3 squared. And notice we're going to get 0 there. And then minus 0, and so our total displacement is 0. So, well, if you wanted to say it out correctly, 9 minus 9, which is 0. So I was doing the math a little too quick in my head. So 9 minus 9 is 0. That's displacement. For the distance traveled, we know is 0 to 3 of the absolute value of v of t dt. And I could show you how to do it out the long way. I can show you guys that in class. I'm just going to show you right now how to do it on the calculator. And so on the calculator, we're going to y equals, we're going to get x squared minus 2x. And then math 9. So we get math 9. Nice thing is that you guys can repeat this if you need to. 0 to 3. Trick here, and I don't remember if I've shown you this before. Alpha trace gives you y1. It's going to be the nicest way for you guys to do it instead of having to go backward, to go back to distribute. Alpha trace y1, x. Now, what did I mess up here? Of course, I did not do absolute values. So, I need to go to math, NUM, absolute value. Again, I'll show you second, or alpha trace, y1. And just hit enter. It's going to take a little bit of time. Math, enter, enter. It does not always work. We need to recognize, though, that 2.666666, if I hit math, enter, enter, is 8/3. It should work. I don't know why it's not, of course. There it is, 8/3. So we do need to recognize that that can go into a fraction. But that's how you do it on the calculator. In case you wanted to know, we could go math 9, 0 to 3 of y1. This is how we do it. The first one, the very first one, 0, 0 equals 0. So that is the total distance traveled. So next question, I want you guys to try this, please, on your own. You are going to have to find C values that are not going to be a 0. And so here are the answers. Not much to say about A. There's me showing that V of 0 equals 24 and finding the C value. The resting part, yep, you got to go back to what we learned in the beginning of derivatives and set the derivative equal to 0. Notice I factored a 3 out, I just didn't show it. Instead of equal to 0, factored. To find the position function, take the integral of V of t. Do that out. Notice that this is where I showed that I used the initial value, or the value of 120. And then here I did use a calculator, so please make sure that you know how to use a calculator. Is going to be critical. You can also do 6 units there. Okay? This is the last example that we'll look at. We are going to look at the average value function in class. Just remind me so I don't forget. So we're initially at rest, and we've got the acceleration. It says the position when t equals 1 is x of 1 equaling 3. And find the values of t for which the particle is at rest. So at rest, we're going to take the integral. To figure out where it's at rest, we got to find velocity, which is the integral function. We'll get 12t cubed over 3 minus 4t plus c. And we'll get 4t cubed minus 4t plus c. Now, it says here, find the values of t for which the particle is at rest. And it says a particle initially at rest moves along the x-axis. So you got to make sure we read everything right there. And so we know if it's initially at rest, we know that v of 0 equals 0. And so therefore, we can say 0 equals 0 minus 0 plus c, so c then equals 0. Those are always the nice ones. So now we have to go and use this. Well, before that, let's we know v of t. Let's answer A before we go on to B. I got ahead of myself there. We can say that v of t equals 4t cubed minus 4t. It's at rest when v of t equals 0, so that implies then 0 equals 4t cubed minus 4t. You guys can try this on your own if you want to. Take out a 4t, t squared minus 1. So we get t equals 0, t equals negative 1, and t equals 1. Now, the reason why I wanted to talk about this is, notice here, even though it's written poorly, t is greater than or equals 0, we can cross that off. So we know it's at rest, the particle is at rest at t equals 0 and t equals 1. Not that you could see any of that. Sorry about it. So that was the answer to A. Write an expression for the position x of t at any time. Notice here that we are going to take the integral of that. So x of t equals the integral of v of t. And we will get that as t to the 4th minus 2t squared plus c. We can use this. You can see that either. Wow. 1 and 3. So you get 3 equals 1 minus 2 plus c. So c equals 4. So we're going to get x of t equals t to the 4th minus 2t squared plus 4. And so now the last one that we have to worry about is total distance. The integral from 0 to 2 of the absolute value of v of t. And so do it in the calculator again. How do I put it in? 0 to 2, absolute value of y1. If you go back to y1, that's what I had put in there. And due to time sense, it's going to equal 136 over 15. A quick joke, what kind of tea is hard to swallow? reality. See you guys in class.